education. I also teach anatomy and physiology. And part of this new approach of offering workshops, so this is the first of many workshops to come, and the intent and goal is to help you with certain topics as you requested. So for me to get a list of what you need, when you're done today, one of those handouts that you had is a survey. And that is your opportunity, basically, to let me know what topic you're interested in. So today we're going to be dealing with acidosis and alkalosis that could be either respiratory-based or metabolic-based. So we're going to start from scratch and deal with pH scale, and then what constitutes acidic and basic environments. And we get to understand how different body systems in our body try to work as a buffer system to prevent sudden fluctuations or extreme fluctuations towards acidic or alkaline environments. So we do that, and then I have a practice for you. You have basically 5 cases based on arterial blood gas values. So once we learn how this works, you get to make diagnosis. And then I will give you the keys so you can compare your answers to your diagnosis to see what you've done. Okay? So starting from very beginning, there is a way for us in the field of science, chemistry and physiology, to determine what constitutes acidic and then alkaline environment. To do that, we use a simple scale that goes from 0 to 14. You probably remember this. pH scale, and then midpoint is 7. That means if your pH, that is potential for hydrogen, by the way. That's what we call pH, potential for hydrogen. What it means is that our calculations based on hydrogen ion concentration in a solution. That's how we determine acidic or alkaline. So next time you hear pH, you're hearing concentration of hydrogen ion. Okay? So at 7, we're dealing with neutral. So there is no acidic or basic environment. So that's sort of a reference point there. If you go from 7 towards 14, you're moving towards alkalinity or becoming more basic and alkaline. So you would have 8, 9, 10, 11, 12, and 13. So moving this way, you're dealing with alkaline or base. And then the opposite is true when you go towards 0. So if you're lowering your pH from 7 all the way to 0, you're moving towards more acidic environment. So what it means is that as you move from 7 towards 0, you're increasing the concentration of hydrogen ion in your solution. So what it means is that you get to increase hydrogen ion concentration, and if you go the other way, you do the opposite. So that lowers your hydrogen ion concentration. So it's safe to say the greater the concentration of hydrogen ion in a solution, the greater the strength of an acid. I'll repeat again. The greater the concentration of hydrogen ion in a solution, the greater the strength of that acid. So if you have 2 acidic solutions with pH of 6 versus pH of 2, which one is stronger acid? 2. There you go. Okay? Now, in chemistry, it's pretty straightforward. When you say 7, that's neutral, that's your reference In physiology, though, it's a different story. Since we're dealing with human body, and in particular, we're dealing with blood, our reference is not 7, because we are slightly alkaline creatures. So when we are healthy, we are actually alkaline. So that's above 7, so pH of blood is 7.35 to 7.45. So that's our normal range. So when you look at your lab values and you get the blood came back and it says the pH is this or pH is that, that's your reference to go by. So what it means is that the term acidosis is acidic environment, right? Versus alkalosis is determined by what number you get here. So that means if you have less than 7.35, you're looking at your pH values, right? So you're looking at acidic. And if you have greater than 7.45, you're looking at alkalosis. So technically, both numbers, if you go by chemistry, technically, this is still base or alkaline, but in blood, we consider it as acidic. So that's a little bit of a difference between chemistry and physiology. So I want you to be clear on that. You don't go by number 7. Our value is 7.35 and then 7.45. So that's as far as how we get to calculate this when you get your labs. Now, there are 3 major body systems that get to play the role of a buffer. So respond to changes in our bodies. And we learned that it's called homeostasis. So to maintain homeostasis and homeostatic balance, we have some ways to kind of play with the chemistry of the blood and chemistry of the body. What are those body systems that you're interested in?
Respiratory.
Very good. So we have respiratory system,
Renal.
and we have renal, and we have digestive system. Very good. So these are the 3 systems that are going to handle different parts of this pH balance. So in your handout, you will see pH values, right? And we learned that is what? 7.35 to 7.45. And then you have concentration of carbon dioxide. We call it P of CO2, or partial pressure gas for carbon dioxide, right? So you have P of CO2, and what do we have? The range.
45. 35 to 45.
35 to 45, right? Okay. And then another major player there is bicarbonates. So I have bicarbonate, and then that range is about 22 to 26, 28. So that's your range, right? Okay. And then you have your partial pressure gas for oxygen. So P of O2, and then you have saturation of oxygen.
Oh,
And those values are,
80 to 100.
okay, so ranges 100, and then you have 90, 95%
To 100.
to 100%. So 2 things, saturation versus presence of oxygen. It's a little bit different in terms of how it's created. That deals with a little bit of Dalton's law and Henry's law of solubility and how it gets to be mixed in plasma, because oxygen in general is insoluble gas, so it's pretty hard for it to become part of plasma. It's mainly handled by hemoglobin and red blood cells, and you're quite familiar with that, I'm sure. So those are important values when you look at them, but really, to deal with acidosis alkalosis, oxygen is not really important. And I'm going to explain how. We only worry about this in terms of whether or not hypoxia exists and whether or not you decide to do oxygen therapy. That's why you look at these, whether you need to give oxygen to a patient or not. Other than that, it's not really part of this, right? I'm going to explain why or why not. So, what I need you to focus on is this. Since we're going to have two versions of acidosis alkalosis. When you say respiratory, and you think about the function of respiratory system, you're dealing with what? Gas exchange. Oxygen versus carbon dioxide. And they have this inverse relationship. So by knowing one, you can predict the other one. So what's going on in respiratory is that oxygen versus carbon dioxide, you will see that they have this inverse relationship. So one goes up, the other one goes down, so on and so forth. But the one that is actually triggering a chemical response is not oxygen, it's carbon dioxide. So our focus is what's going on with carbon dioxide concentration. And the reason for that is a simple chemical reaction, okay? And that is when we have CO2 and we got plenty of water, more than half of the body is water, right? So plenty of that, plus